Hello, this is our third video on circular motion for A-level physics, and we're today going to look at centripetal force. First of all, let's consider the Sun at the centre, and of course our Earth that's orbiting, and we need to imagine this as a circle. A couple of questions for you to consider. Number one, if the Sun disappears, what's going to happen to the Earth? And number two, if the Earth suddenly started moving faster, what would happen? Have a think, and when you're ready, press play to continue. Okay, hopefully you've given that some thought. Let's have a look. First of all, before we answer the question, let's just remember that the Earth is attracted to the Sun, so there's a force due to gravity acting inwards, but the Earth is also moving forwards with a certain velocity, and they're independent of each other, so they're at right angles. So if the Sun disappeared, well, that means there'd be no more force, so the Earth is going to move off at a tangent. And number two, if the Earth suddenly moved faster, what would happen? Well, at the minute, everything's balanced, so we get something called circular motion, so it's just going around in a circle quite happily. However, if it moves faster, then this arrow suddenly gets bigger, and it'll therefore unbalance things, and what will happen is the Earth would gradually leave and move further away from the Sun. So with that in mind, let's focus on the force, or we call it the centripetal force. And what that does is it keeps a body moving with uniform speed in a circular path. At all points around in the circle, that force is always acting towards the Sun, or the middle of the circle. Sometimes you might get asked about what the work done is. Well, work done is force times distance moved in the direction of the force. But as we've just mentioned, the velocity and the force are perpendicular to each other. So because they're always at right angles, no work is done because they're in different directions. They are independent of each other. Let's go back to our equations and consider one that we've used for many years. Velocity equals distance divided by time, and also omega equals 2 pi f, or angular velocity, and that can be rewritten as 2 pi over t for time period. When talking about a circle or circular motion, we can therefore say the distance is 2 pi r, because that's the circumference of a circle, and the time it takes is t, the time period, so velocity 2 pi r divided by t. But you may have noticed that 2 pi divided by t has already been rewritten over here, so we can make another equation by merging these two together. So the velocity equals omega times r, where r is the radius. Now if we assume the angular velocity does not change, what this equation tells us is that v would be directly proportional to r, the velocity, directly proportional to the radius. So if you double the radius, you would double the velocity in order to keep the angular velocity the same. We're now at the end of this short video. If you have any questions, get back to me, and as ever, remember to subscribe.